Now let's focus on the installation of Red Hat Enterprise Linux with logical volume management. LVM provides a way to create volume sets that can spread across multiple physical disks or be constrained to one physical disk, although not recommended. It provides a way to resize either up or down, larger or smaller, volumes on the fly while the operating system is up and running. It also provides a way to aggregate storage across disparate technologies such as IDE, ATAPI, SCSI, SATA, so on and so forth. We'll let us boot up and start with Linux ask method. So we're back to the main menu. Again, we're using the boot ISO image as opposed to the first CD of 5 or the DVD with the binaries on it. We're using the small 7.2 megabyte boot ISO image, which will then give us the ability to connect to the network and install the remainder of the packages. In order to do so, we'll indicate Linux ask method, and we prefer that we enter the graphical mode as it provides an easy-to-use interface. However, the text-based interface supports both LVM as well as RAID and the other options that you can perform or interact with using the graphical installer. So Linux ask method will begin the process. And now we're booting, the drivers are loading, the common drivers that are common to most widely used hardware options within the PC environment. And we'll select our language options as normal. The source is HTTP. IPv4 and 6 support is auto turned on. If you want to disable either or, simply deselect the asterisk next to the option. You can install, by the way, using IPv6. You're not restricted to version 4. However, there is a restriction when using NFS that you use IPv4. Otherwise, when using HTTP, FTP, and other methodologies, you can use IPv6. Let's insert the IP address of the distribution server, the source installation server, and its relative directory is /RH5 relative to the web root, that is I386. Again, you don't have to lay out your directory structure this way. You can lay it out any way you see fit, so long as you reference the path to the top level directory equivalent to the top level directory of the DVD accordingly. In this case, RH5 /I386 takes us to the top level of where we copied or where we mounted the ISO image, that is, equivalent to copying the contents of the DVD to the web root. This will reach out to the network and get the stage 2 image and other applicable files. Once you see retrieving images, stage 2 image, you know that your networking support is working. If you get a failure at this point, chances are your DHCP server has not assigned you an IP address, or perhaps your system's a multi-home system, maybe it has multiple network interfaces, and perhaps you have the wrong one plugged in to your local area network. Let's proceed. And when we get to the partitioning section, we'll remove the RAID partitions, although you can create LVM partitions that are based on RAID partitions. We'll skip the installation number. Only apply the installation number for your true production servers, or servers that are using your production setting. If you're simply testing, then you don't need the updates. We'll install a clean copy as opposed to upgrading the existing installation. Here are the disks. Again, advanced storage configuration allows you to connect to iSCSI targets. We'll change this to create custom layout. That's the option you need to select in order to interact with the interface, the disk druid interface, to create LVM, RAID, and various partition types. We want to delete the partitions that are on the drive. Now you can select the partition independently, but if it belongs to a RAID set, you first need to get rid of that set. So the RAID set ties it all together. Otherwise, the interface complains that the individual software RAID partitions belong to a RAID device. You can clean up your partitions by selecting them from the graphical interface above. And once you see free space associated with the drive, then you know that it is raw storage and can be reassigned to LVM. So let's clean everything up. We'll remove the small partition that you see here. And we'll get rid of this as well. Plus a small space which was used for swap. The second is free, and the third disk is also free because it had a software RAID partition. So now we've got 3 free disks. So to set up LVM, it's premised on defining physical volumes. You first need to define physical LVM volumes, volumes that can be used with LVM. After you've defined those physical volumes, you associate them with a volume group, and then you create a logical volume. So there are basically 3 steps that are involved in creating an LVM presented volume. And it tells you here at least one unused physical volume partition is needed to create an LVM volume group. So we need to create one or more partitions that are physical LVM volumes and associate those volumes with an LVM volume group. Once we've got an LVM volume group, we can create one or more logical volumes out of the volume group. Again, the default installation creates LVMs, or logical volumes. That is, if you select no partition types and just go with the default layout, it auto-creates for us logical volumes. So we need to find some space. Here's an ext3 that we didn't remove. Let's remove it. And you need to also determine whether or not you want your boot partition to be a part of the logical volume. Generally, I opt for it not to be, just to keep it separated from the logical volume, but there's nothing preventing you from doing so. Let's go ahead and create a new partition. The mount point will be for boot. It'll belong to the first disk, so we'll deselect the superfluous disks, and it'll be 100 megabytes. That'll take care of the boot partition, and if you want it to be a primary partition, go ahead and force it below. And now we've got a boot partition. Now we can use the remaining space, or the bulk of the remaining space, to create LVM physical volumes. So we need to determine of the free space what would be ideal. So we've got roughly 36 gigabytes free per disk. So we'll go ahead and use 20 gigs like we did earlier. But the main difference that you'll see with LVM is that no space is wasted, or we don't forfeit any space for parity information. So in the free space, you want to create a new type of partition. We'll navigate to physical volume, and just like before, set it to 20,000 megabytes, which is roughly 20 gigabytes. It doesn't need to be a primary partition. So that's our first physical volume. Again, if we were creating LVM partitions from the file system or from the command line while the system's up and running, this is the first thing we'd do. We'd create physical volumes using pv-create followed by the name of the partition in the dev tree. So it would be /dev/SDA2. On the second disk, new partition, no mount point, just navigate to physical volume, deselect the superfluous drives, and set the size of the volume. Ditto for the third disk. We're going to create a 20 gigabyte physical LVM volume. We'll deselect SDA, SDB, and change 100 megabytes to 20,000 megabytes. So now we have 3 physical volumes spread across 3 physical disks, which will improve performance. The information that we write will be written sequentially, meaning the data will consume, unlike with RAID 5 or with mirroring, the data will consume, or even with RAID 0, where the stripes are written across all 3 disks, or all 2 disks, or whatever number of disks are in the volume set. The data will consume the first disk, then the second, then the third, so it's written in a sequential fashion. So we have 3 physical volumes, 20 gigabytes each. Now we can create a volume group based on those physical volumes. So again, if the system were up and running and we had to assign or allocate the storage to LVM, we'd first issue the pv-create command against the local partitions. Then we'd create the volume group with the vg-create command, assigning the disks to the volume group, followed by the lv-create command, which creates the logical volume. And again, with a volume group, you can create one or more logical volumes for various usage, such as for var, opt, / itself for root, so on and so forth. Let's navigate to LVM. So now we're going to end up with 60 gigabytes of storage in the volume group. The default name is volgroup00, but you can call it anything you want. The physical extent size that will be written, 32 megabytes, but you can switch this from as small as 1 to 128. 32 is a good size for writing chunks across the board. And here are the disks that will be associated with this volume group, totaling 60,000 megabytes, or about 60 gigabytes. We can then add logical volumes and mount points and sizes by clicking on Add, determining what the mount point will be, for example, beginning with root, and determining the size. So instead of using all of it for the root, let's make root 10 gigabytes. A file system of type ext3 will be associated with it. You need to overlay a file system, that's important. Now we've got about 10 gigabytes to log vol00. It's named for you by default unless you specify a name. You can call it root or just leave the default nomenclature. Let's create another logical volume. This will be for a different mount point for home, and it'll be logical volume 01. And instead of 10 gigabytes, we'll make it 5 gigabytes. And as you create mount points, the remaining space will be reflected in this area where it says max size. So now we've got root as well as home. Let's create yet another logical volume, and it increments by 1. This will be log vol2. And we'll make this the user space where software is typically installed. We'll also make this 5 gigabytes, or about 5 gigabytes, which leaves us about 45 gigabytes to use, which means we can always extend the storage as we see fit, or as our users deplete our resources. So we've got root home user. Let's add yet another volume, log vol3. This will be for var. Let's make var 10 gigabytes to house all of our log files, which will leave us about 30 gigabytes free. Let's go ahead and add again. And we've got some additional options such as user local, opt, as well as temp. We'll create one for temp, temporary storage, and we'll make it 5 gigabytes. And it's log vol 04, which leaves us about 25 gigabytes free. So then we've got about 25 gigabytes, which is the maximum size available free. And at this stage we can determine to leave the free space for expansion of any of these logical volumes. Again, the beauty of logical volume management is the ability to resize any of these partitions at any point. So if root contains the full or occupies the full 10 gigabytes very quickly, we can make a few changes, perhaps reboot the system, and then all of a sudden root will be expanded to, let's say, 15 gigabytes, 20 gigabytes. So it's very easy to resize file systems when using logical volume management. It also is very easy to spread your storage across multiple disks, which improves performance. So we have multiple partitions. So this lesson or section here focuses on custom partitioning using logical volume management during installation. We'll go ahead and click on OK. We've yet to define a swap partition, but we've got volgroup 00, that is, which includes multiple logical volumes for different mount points, temp, var, root, user, and home. Super. Now at this stage, we should create swap somewhere. Let's do so on the second disk where there's free space. Click on New, File system type, swap, and we'll set it to be, this is on the second disk, so we'll deselect the third and the first. We'll set it to be twice random access memory, or 1024 megabytes. And now we've got swap, and now our partition table is set, and we still have tons of free space left for expansion. Both within the individual physical volumes, which are associated with the volume group, as well as within the free space left on each of the disks in the event that we need to expand the underlying physical volumes. Again, logical volume management provides all of this flexibility, the ability to rework your storage on the fly, and in many cases without having to reboot or interrupting user access. So with that said, let's move forward in the installation. We've laid out a custom partition, and the root partition will be located within the dev tree vol group 00, logical volume 00. It's important that we use a bootloader password for security, which will be encrypted in the grub configuration file for our safety in the event that the system's physically compromised. We'll click next to move on. DHCP will configure the interface, but will manually name the system. And then we'll move forward. The time zone set, system clock currently does not use UTC. And we'll have to assign a root password. As you can see, regardless of the way we lay out the disks, the installation is pretty consistent. The forms that are presented are relatively consistent. So with that said, we're presented with default software categories, but if you'd like to customize the software, navigate to Customize Now, navigate to Next, and then we're presented with the categories we saw earlier on. So pick the software that's of interest under each category, such as applications, development, if you need development libraries, but just lengthens the installation process. Various network servers, DNS, that's bind, FTP, legacy network server, RSH, Telnet, so on and so forth. So you can select what you need up front, or once the system's up and running, use the add remove programs program, and you'll be able to set it up pretty transparently. There are various administration tools that are available. If you navigate in, you'll see them. System config based tools. The loan package that's not installed is system config kickstart. We'll select it because we'd like to look at the kickstart package as one of our installation options. So that's installed. If you need any languages, additional languages for other users using your system, then go ahead and select it. But these are the basic categories. We'll keep it slim, but again, the one thing that we did turn on beneath base system administrative tools is the system-config-kickstart utility. That utility will allow us to graphically interact with the anaconda-ks.cfg file, or allow us to create a new kickstart configuration file that we can then use in a hands-free installation setting. So let's go ahead and click on Next to move forward in the installation. The dependencies will be resolved. Again, one of the objectives of examination or certification is that you're able to perform a Kickstart-based installation as per the Red Hat information on their website. So with that said, you do need to know how to use Kickstart to lay out a setup, or at least know how to use Kickstart to reset up your system or set up a new system based on a previously installed system. Since every installation of Red Hat creates the anaconda-ks.cfg file in root's home directory in addition to the install.log file. So we always have a template after we've installed the operating system that can be then applied to similar systems. And by similar, we mean systems that have similar disk layouts in the event of LVM, for example. So it wouldn't help if you were to take the anaconda-ks.cfg generated by this installation and applied it to a system that doesn't have 3 physical disks that could be used to lay out LVM partitions. However, If you do have multiple identical systems, Anaconda ks.cfg can be renamed and used. So for example, let's say you're setting up 10 or 20 or 50 or 100 identical servers, physically identical. Set up one server, copy the anaconda-ks.cfg file to an accessible location such as an HTTP web server, IIS, Apache, what have you, and reference that ks.cfg file during installation. Just boot with your boot.iso CD, and when the main menu comes up, simply indicate ks equals and the full HTTP URI, such as http:// the IP address of the system, such as 192.168.75.100/ks.cfg, or wherever you happen to have placed the ks.cfg file. And then, if all of the answers or all the questions have been answered, the installation questions have been answered correctly, the installation will proceed by and large without any interaction or without your intervention. The file systems are currently being formatted, and as you've grown accustomed to, we're now stepping through the standard installation forms and processes, which includes file system formatting and the copying of the different RPM packages. Now, this version of Linux, Red Hat, represents its packages or stores its applications in a format known as RPM, Red Hat Package Manager format. So you'll find that on the installation DVD or CD, that in the platform directory beneath either server or client, that you find a list of RPM files. Those RPM files house the programs that you use within the environment. Whereas conversely, on a Debian system, you will find that the DVD or CDs contain .deb files, which are the package format, or which represent the package format used within the Debian space. Nonetheless, whenever using a Linux distribution that has package management, which most, if not all, modern Linux distributions do nowadays, we'll find that the programs are represented using the package management format of choice. SUSE Linux and Red Hat Linux both use RPM, or Red Hat Package Management format. And these are the programs that we see being copied, such as glibc common 2.5, the version number, .rpm. The architecture is always included. So if you look at any of these packages that are flying by on the screen, they include a name, a major or main version, a minor version, patched information version from the distributor, in this case Red Hat, followed by the architecture. Let's wait for a big package here. You'll see like i386 in the package. This is the way the distributor of the packages keeps track of the platform-specific packages, as different platforms require different packages. So 64-bit versus 32-bit versus, let's say, in the case of Debian, Spark, MIPS, or in the case of Red Hat, SUSE, IBM, S370, and other types. In other words, each platform has its set of binaries that the distributor supports, but you'll see a consistent nomenclature. Name, version, which includes major, minor, and patched version. Also the architecture. Now, some packages have no architecture, which means they're not architecture specific, which also means you can install them on any architecture supported by the distribution of Linux. In addition, you'll see the size in between parentheses for each of the packages being installed, a brief description, link to release notes, which you should read while the installation proceeds to see if there is anything that's specific to your environment. Over to the right, the remaining time, 10 minutes. And also in the background, you have multiple consoles, Control-Alt F1 through F6, which provide useful information regarding the status of installation, such as what packages have been installed, if there are any errors copying the package to install the package from the network resource or from the local media, such as CD or DVD, as well as device configuration for hard drives, network interfaces, the detected processors, the amount of RAM, the file systems that were created, how they were created, if they were created successfully, so on and so forth. So all that information is presented in the background on the various Control-Alt screens. So, for example, I've pressed Control-Alt F1 here. This is the original screen which launched the graphical installer. It includes information regarding the fact that it's going to start in graphical mode. This is Control-Alt F2, which provides a single user shell which you can use to interact with the installation process as it proceeds. You can see the directories as they're being created and execute some of the common commands such as ls, df-h, where you'll see that the different partitions we've laid out in the volume groups are all in place. Here's dev vol group 00, which with logical volume 0 through 4, representing the different partitions, and they're mounted temporarily during installation beneath mount sysimage and the appropriate names such as var user home, root for log vol 00, etc. So that's on Control Alt F2. Again, Control Alt F1 is the original screen. Control Alt F2 is a single user shell. You know because it's indicated below sh-3.1. Besides, during installation, services aren't available, so multi-user mode would not be available or made available. That's Control Alt F2. Control Alt F3 contains information regarding installation. This is typical logging information, which includes categorical information like info, warning, syslog related information, what's transpired during the installation with respect to the disks, for example. That's on Control Alt F3, a running log. Control Alt F4 has more disk information, as well as SE Linux information, and if there are any IO errors and any other trouble during the process. Control Alt F5 contains grub-related information. This is where grub goes to work, as well as the allocation of file systems. So anything to do with your file system and grub, the bootloader, takes place on Control Alt F5. Now we'll return to the main screen, Control Alt F6, the graphical screen, that is. And at this point the installation's over, so we need to move forward with rebooting. And here we are, back to the boot menu. It happens very quickly. Initialization, we'll eject the CD to be sure that it doesn't boot to the installation program. And we'll have the main menu after the hard drives have been detected momentarily. And then we'll boot up, again in single user mode, just to skip or to bypass the form, the installation form, which prompts us for information regarding time zone, network time protocol, product registration, so on and so forth. And we'll use DF to take a look at the partitions. Again, here's the main menu. In order to interact with grub, we'll have to press P to specify the password. And if it's correct, it'll accept it. Then E to edit. We'll modify the kernel line, not the root line. The root line references the hard drive that's to be used to boot the system. Grub allows you to boot from a different hard drive, so if you've connected another drive such as HD1, then by all means modify the root line in the grub configuration file. Otherwise, leave it the way it is because it references the first hard drive. The init-RD should also not be touched because it's required to load drivers necessary to access the storage subsystem on this particular system and on most PCs. We'll edit and just append the option single, which will cause Linux to start in single user mode. So let's press B to boot, and if you just read through the menu, you'll see that B is the option to boot after you've edited, and this will take us in. And now we're starting up again in single user mode with the logical volumes coming up in a clean state. So let's confirm that all the volumes are in place. We'll close screen and execute df-h, and there you see beneath dev mapper the name of the volume group, each of the logical volumes. 00 represents root, which is about 10 gigabytes. 01 represents home, about 5 gigabytes. 02 represents user, about 5. 03 is var, it's about 10. 04 is the temp mount point, which is about 5 gigabytes. And the boot mount point has its own partition on the first hard drive, and it's the first partition, SDA1. It's about 100 megabytes. We've also got a tempfs entry used by the kernel, and that's our logical volume layout. Now there are LVM tools, such as PV display, for example, which will display the physical volumes on the system, SDA1 through SDB1 and SDC1, which includes the size of each of the volumes, about 20 gigabytes each. So PV display displays the physical volumes, whereas VG display displays the volume groups. There we see there's one volume group, 00, and this volume group is sized at about 60 gigabytes, of which we have access to all of it. It also lists in its status field the fact that it's resizable, and the access is read-write. You can also use LVM, which brings up another point that eluded us, to create read-only volumes, which are useful in many instances, analogous to an ISO image where it cannot be written to. So you can use LVM to share out volumes, resize volumes that are read-only. LV display displays the logical volumes, 0 through 4, including their sizes, their extents, the unique user IDs associated with them, and their locations in the dev tree. So you've got 3 sets of tools to help you interact with logical volume management, which we'll look at later on. PV, VG, and LV related tools such as PV display, VG display, and LV display. Now with that said, we're up with logical volumes. You know how to create them during installation using the graphical installer, and we're going to reboot to complete this installation. As mentioned, however, in the root's home directory, you'll find the configuration file anaconda.ks.cfg. The less of it reveals the options that were specified during this installation, including where to get the source files, the binary files that is, so the source of the binary files, what to skip, the language format, the keyboard format, the network device and its host name that should be applied, and the protocol, in this case DHCP as opposed to static, the encrypted boot password, which is the grub password, the fact that the firewall is enabled, but it permits port 22 access, that's the default firewall configuration, allowing SSH into the box, and DNS and DHCP replies, as well as other replies for web requests or any requests sourced from the system. The fact that for passwords we have shadow and MD5 turned on. If you want stronger encryption on your password files, you could use SHA-1, for example. The SE Linux policy is set to enforcing the time zone. Again, these are all answers to questions presented to us during the installation process. Where the bootloader is to be placed in the master boot record, the order of the drives, SDA through C, in that order. The options that are to be appended to the boot option or to the kernel boot option when grub calls the kernel. The password to associate, and partition information below. If you scroll down, you'll see what it does with the partitions. And we'll just spacebar to go one page down. Here you see the specifications for the logical volumes. These items are commented, by the way. Any item in a Kickstart configuration file that's prefixed with a hash mark is commented, and for good reason. Again, if you take this Kickstart file and attempt to install it in a system that doesn't have 3 physical disks labeled SDA, SDB, and SDC, the installation will fail or prompt you to lay out the disks. But if you're confident in the layout of the disks on the other systems, for example, if you use this Kickstart file on this local system or on identical systems, then uncomment all of the lines that pertain to disk configuration, minus these lines which are truly comments. It tells you here, following is the partition information you requested. Note that any partitions you deleted are not expressed, so on and so forth. It's not guaranteed to work, which is why it is commented. Also, prior to the creation of the partitions, we see clear part followed by Linux, which means it'll clear all Linux partitions from all of the disks on the system. It shows that a partition for boot is to be created with file system type ext3 size 100 on the SDA disk as a primary partition. And it shows the different physical volumes that are to be created for usage within logical volume management. So we see 20 gigabytes on SDC, 20 gigabytes on SDB, and 20 gigabytes on SDA, each with unique identification values, 14, 13, and 12 respectively. We see that a swap partition is to be created of size 1024 on SDB. We see that a volume group is to be created, vol group 00, with physical extent size of 32K in this case, or 32 megabytes in this case, 32,768 kilobytes or 32 megabytes to include the physical volumes 12, 13, and 14. We see that logical volumes are to be created for temp, var, root, user, and home with various attributes for size, volume group association, and logical volume name, as well as file system type. Once the partitioning has been taken care of, we see information related to the packages that are to be installed. These are various classes of packages that we saw in the installation in the GUI interface, that is, such as Office, Editors, Text Internet, so on and so forth. After the packages, we have a sys report and few other options, and it's over. The installation is complete. Now, there is the ability with Kickstart scripts to execute commands pre and post installation. So just keep that in mind in the event that you need to perhaps connect to the network, send an email with a shell script, or write a log entry somewhere so that you're notified that the system has been completed or has completed its installation. So with that said, this system's up and running with logical volume management. We can move on to other installation types. We'll reboot it.